Okay, today our experiment is about measuring the free fall acceleration or acceleration due to gravity. We are going to use kinematic equation to find the value of g. So the equation we're going to use in our experiment, delta x, which is the height, equals half gt squared. What we're going to do, we're going to drop the ball from different height, and each time we're going to measure the time the ball takes to reach the ground. And we're going to repeat this 3 times for each height. Now, the equation of a straight line is y equals mx plus c. C is y-intercept. We don't have y-intercept, so our line should pass through the origin. Height will be on y-axis and time square will be x-axis. So when we graph, we have to graph a relationship between height, delta x, and t square on x-axis. Now we should get a straight line. The slope of this straight line, or the gradient, the slope, which is rise over run, will represent half g. So half g is the slope. So we have to get the value of the slope in order to find g. Now let's go to Excel now. This is one of measurements done by one of group of students during our experiment in the lab. Now, how I'm going to use Excel to simplify our calculation. Of course, you can use normal method to do it, but also you can use Excel. So I'm here to teach you how to use Excel to find all of this calculation. First, since we repeated the experiment 3 times, I have to find the average t. So to find the average t, I'm going to put equal average. Normally, you have to add them all divided by, I repeated the experiment 3 times, so divided by 3. So here I have equal, write the word av. You see here we have a list of choices. Here I'm going to double click on the second one. This is the average. And then go and select all the values in the same row, the values of t. Close the bracket and hit enter. Now I need Excel to calculate the rest of my calculation for me. So if you hover your mouse over this cell, you will notice here a small square at the bottom right corner. When the mouse pointer changes to a plus sign, click and drag it downwards. Excel will then automatically complete the rest of calculation for you. I need to find t square. So put equal, go and select t, hit shift with number 6. Okay, and then put 2, this is the square, hit enter. Repeat the same steps again, drag this all the way down. Now, how to make sure that the accuracy of my measurements, we need to calculate the value of g value using kinematic equation, the same equation. So if we calculate the value of g and matches the standard value of g, which is 9.81, that will confirm our measurements are accurate. Now remember, this is the equation. So I need to separate g, and I write equation just in terms of g. So if I make cross multiplication, I will get 2 delta x equals g t square. Divide both sides by t square. and g will be 2 delta x divided by t squared. So this is the equation. So you have to multiply 2 times the height and then divide it by t squared. So here equal, open bracket, 2 times in Excel is shift with number 8. 2 times the height, this is the height, close the bracket. Division is forward slash, so this is the division, divided by t squared. T squared, just put your mouse on the value of t squared in the first cell, this one, and then hit enter. Drag this all the way down. You see my measurements are close to the actual value of G, which is 9.81, so it matches this value. So my measurements are accurate and precise. Now, second step, I have to graph a relationship between delta x and t squared. We said this will represent y axis and the x axis, and this will represent y axis. So you have two options. Either you do it on the same sheet, or for simplicity, just copy the height column with t squared column in another sheet. So I have t squared, this will represent x-axis, and y squared. I'm going to select these values and then go to Insert, Scatter. Okay. Go to any points here on the scatter, right-click, and then add trend line. You should get straight line, make sure it's linear. Make sure it starts with 0, so set the intercept from 0 and display the equation. I can add axis, go to plus sign here at the right corner of the chart and select axis title. I have to label my axis so here I have, this is height, and you have to write the unit. Here I have meter. Okay, and here this one I have time. So here this one is time square. So t square, t square, and you have to write the unit as well. So t square, or time square. Square, and the unit will be second square. I would like you to look at this equation. I have y equal the slope times x. Y equals 4.8 times x. Let's go back here. Okay. So the value of the slope I've got, slope m, equals 4.88. This is the slope. Now I'm going to leave this one for you. You have to do it yourself. How can I find the value of g? And the other thing, how can I verify and I compare the value of g that I've got from my experiment with the standard value of g? What should I do? So I'm going to leave this for you to write it in your lab report.